Hi, I am Arjun from CSS Cybersecurity branch of Institute of Aeronautical Engineering College. Today, I am going to discuss about the topic in probability and statistics of point estimation and interval estimation. Here, what is estimators? Firstly, in statistics, an estimator is a function of the data or sample that is used to interfere the value of an unknown parameter in population in a statistical model. Thus, the estimator, the quantity of interest, the estimated or a parameter and its result, the estimate are different from each other. Qualities of estimators. Statisticians have already determined the best way to estimate a population parameter. Qualities desirable in estimation include unbiasedness, constancy, and relative efficiency. An unbiased estimator is a population parameter is an estimator whose expected value is equal to the parameter. An unbiased estimator is said to be consistent if the difference between the estimator and the parameter grows as small as the sample size grows larger. If there are two unbiased estimators of a parameter, the one of whose variance is smaller is said to be relatively efficient. Point and interval estimation. For example, suppose we want to estimate the mean summer income of a class of a business students for suppose for n equal to 25 students. It is calculated as the average is found to be $400 per week. X bar is the point estimate, and an alternative statement is the mean income is between 380 to $420 per week. The objective of estimation is to determine the approximate value of population parameter on the basis of the sample statistic. There are two types of estimators, point estimator and interval estimator. Point estimator draws interference about a population by estimating the value of an unknown parameter using a single value or point. We saw earlier that point probabilities in continuous distributions were virtually zero. Likewise, we would expect that the point estimator gets closer to the parameter value with an increased sample size, but the pointer estimator don't reflect the effects of the large sample size. Hence, we employ the interval estimator to estimate population parameters. An interval estimator draws inference about a population by estimating the value of an unknown parameter using an interval. This is why we say with some percent certainty that the population parameter of interest is between some lower and upper bounds. Statistical interference, that is estimation. Good. How can we use a sample data to estimate values of population parameters? Point estimate. A single statistic value that is best guess for parameter value. Interval estimate. An interval of numbers around the point estimate that has a fixed value, that is confidence level of containing the parameter value called a confidence interval. Point estimators most common to use sample values, that is mu is equals to y bar, that is sigma yi by n. Sample standard deviation estimates population standard deviation sigma. Sigma bar is the s under root of sigma yi minus y bar whole square by n minus 1. Methods of finding estimator. In point estimators, the method of movement, maximum likelihood estimators, Bayes estimator, the EM algorithms are used. In interval estimators, inverting a test statistic, pivotal quantities, pivoting the CDF, and Bayesian intervals are used. Confidence interval. Confidence interval of a parameter consists of an interval of number along a probability, that is interval contains the unknown parameters. A confidence interval gives a range esteem of values, takes into consideration variation in sample statistics from sample to sample. Based on all the observations from one sample, gives information about closeness to unknown population parameters stated in terms of level of confidence. For example, 95% confidence, 99% confidence can never be 100% confident. A confidence interval estimate of 100% would be so wide as to be meaningless for practical decision making. The larger the CI, the more confident we can be that the given interval contains the unknown parameter. Ideally, we prefer a short interval with a high degree of confidence. For example, we'll prefer 90 or 100 with 95% confidence than 0, 100 with 100% confidence. The values corresponding to a significance level that determines the test statistics that led to rejection of null hypothesis and those that led to a decision not to reject null hypothesis is referred to a critical value. Confidence level estimations. The general formula for all confidence intervals is point estimate plus or minus critical value into standard error. Because the level of significance alpha, because we only select one sample and mu or pi are unknown, we never really know whether the confidence interval includes the true population mean or proportion or not. The level of significance or alpha risk is the chance we take that the true population parameter is not contained in the confidence interval. Therefore, a 95% confidence interval would have an alpha of 5%. Here we can see the graph. If alpha equal to 0.05, then each tail has 0.25 area. Alpha is the proportion in the tails of sampling distribution that is outside the established confidence interval. The critical values of Z that are defined the alpha areas are minus 1.96 and plus 1.96. Level of confidence. Level of confidence is a confidence interval in a probability that represents the percentage of intervals that will contain if a large number of repeated samples are obtained. The level of confidence is denoted. For example, a 95% level of confidence would mean that if 100 confidence intervals were constructed, each based on different sample from the sample same population, we would expect 95% of intervals to contain the population mean. Constructing confidence interval. The construction of confidence interval for the population mean depends upon three factors. One, the point estimate of the population, the level of confidence, the standard deviation of the sample, sigma x equal to sigma by root n. Constructing confidence interval. Select our desired level of confidence. Let's suppose we want to construct an interval using 95% confidence level. Calculate alpha and alpha by 2. 1 minus alpha into 100% equal to 95%, where alpha equal to 0.05, alpha by 2 equal to 0.025. Look up the corresponding Z score. Alpha by 2 equal to 0.025, a Z score of 1.96. Multiplying the Z score with the standard error to find the margin of the error. That is 1.96 into sigma by root n. Next, find the interval by adding and subtracting these product from the mean. You can see the graph where sigma x equal to sigma by root n. Here is a table of commonly used confidence levels, that is alpha and alpha by 2 values and corresponding Z scores which are using in our examples. Thank you. Thank you for giving this opportunity.